Good morning, everybody. So, let us start our class in this morning. I see only, I'm sorry, I see only 7 people here in face-to-face class, and I see there are 17 more online. Okay. So there are about 100 students. So, yeah, everybody please join in. Okay. So, you can join in virtually online on Team. Okay, and since this class size now attendance size is small, so everybody, if there is no background noise in your site, then keep your me unmuted. You can keep unmuted and interact. Okay, and interact with us frequently. Okay, so whenever you have any question or anything, so then
Someone has a question online. He says,
yes.
when will our test be graded?
Yeah, test is almost graded. I'm not grading test 1. So I saw that it is almost finished. Maybe it will be published maybe today or tomorrow. Hopefully tonight or tomorrow. So I saw that is almost 95% grade was completed. You know that there are more than 1,000 students took the test. So a lot of students. Okay, and so as usual, so let us look at our schedule first. So according to our schedule, so we are in the week of 7th week, right? So you see that we are past halfway of this course, right?
I don't think we can see your screen. At least I can't.
Oh, you cannot see my screen?
I can't either.
No, we can't see it.
Okay. Now can you see my screen? You should be able to see now. Do you see my screen?
Yes,
Yes.
we can now.
Okay, yeah, thank you. Here I'm trying to display my screen on this. So I think it has problem. Still, it has problem. Please join in team. People who are joining online here. Give me one more second. I'm trying to. Okay, so sorry, the main projector does not work. Okay, so as you see that we are at the middle of this course. We have completed 50% of the stuff. But so this module 5, we will discuss module 5. Okay, so then we started in our last week. So one day array and searching algorithm. So today maybe we will complete searching algorithm and we will start sorting algorithms. Okay, so we are on module 5 today. And I think at this point you should get interest in programming. So if you practice programming, then I think you should have interest in programming right now. So more interesting stuffs are coming, and these are the central point of programming structure. Okay, so we will start module this one, searching and sorting algorithms. If you remember in our last lecture that we discussed we started with linear search algorithm. Linear searching means finding out a specific element from a list or an array, right? So we want to see whether a specific element exists or not in an array. If it exists, how many times it exists, or if it exists, what is the location of that element, or if it does not exist at all, then you can give a message that it does not exist. So there are several algorithms that are called searching process. Okay, the process is called searching algorithm, right? So searching algorithm, there are several searching algorithms. Two of those we will learn. First of all is linear search algorithms. I'm sorry. And the second one is binary search algorithm. In a linear search algorithm, we start from the beginning of an array and go one by one until the last element. Okay, so we may be lucky enough that we can find our desired element, target element at the beginning, or we may find all the way end, or in the worst case we may not find it, right? So still we have to traverse or search all the elements from starting from beginning to all the way end. This is why if the arrays of list size is n, okay, then in the worst case we have to check for all elements. This is called big O notation. It's uppercase O. When you take algorithm course, you will learn how to calculate this algorithmic notation. So this notation, it is used to find the efficiency of an algorithm. Okay. So you remember that the linear search algorithm efficiency like big O n. That means the best case or the worst case, you have to search for all elements. That is not bad. Okay, although it's not good. In some cases, you will see that you may need to loop through multiple times. So for instance, you will see there are some algorithms that takes n squared time. Some algorithms that takes n cubed. Those are the worst algorithm. Okay, for large data size, that algorithm is not an efficient algorithm because it takes long time for large data size. For small data size, it is not a matter. But there are luckily there is another way we will see that the binary search algorithm, it takes way less amount of time. The log in time. Okay, we will discuss this. Okay, so we started with the binary search algorithm. What do? We create a list and then we put our target value, and this is called a flag. So initially this flag is set up as false. And if we find an element, then we say this flag is okay, and then we see. So this is the algorithm for binary linear search algorithm. Okay, so then in the last class we discussed this. Okay, so this is in Java and this is in C#. In C#, it is a little bit different. You see that in Java it is L length. All array by default has this attribute length. It auto detects the length of the array. So, but in pseudocode format, in C# you will type in L is in uppercase. That is the difference, right? Okay, so this is the algorithm part, and then in our last lecture we discussed this. But in C++ it is different. Okay. So in our last lecture we discussed this program, right? We discussed this program maybe, and today so let us start from there. Okay. So if I go to my Replit account and searching, right? So linear search example. Okay, linear search. I say array search. Okay, let me see which one we discussed in our last lecture. Actually, this is the code. Okay, linear search. So let me create a new program. Sorry, I'm getting slow connection. My computer is frozen. Okay. So in our last lecture, we discussed that. So we start here, my program is concise, is written with find a number method. Okay, so we will discuss method in next week. So we have, in this method, we pass an argument, an array as an argument. I'm sorry, my computer is frozen. It's not working. Okay. If I click here, it gets frozen. I don't know. It's not working. Okay, if it works, then I will come back to my program. Otherwise, let us go with slides. Okay. So linear search algorithm is straightforward. Okay, but there is another search algorithm. It's called binary search algorithm. Sorry, my computer is not frozen. I think I have some programs open. Let me close those. It gets more memory. I'm sorry, my computer got frozen. Okay, it's coming up. That's good. No. Okay. I'm sorry, my computer is not working. So these are the actually program codes from line number 7 to 10. Okay, I have still an hour. So yeah, you please stay online. I'm restarting my computer. Okay, so let me see. See me?
Yes.
Yes.
Thank you. Thank you. Fine. Okay, so actually these are the codes. Okay, this line is the code, these few lines for linear search algorithm. Okay, so what happened actually, we need to put these lines of code in our main method. These lines of code in our, usually forget about this if we do not have this, if we do not understand methods. So what we do need to do, so this is our main method, right? So this is our main method. So here we have, for instance, we have an array. Okay, so for now let us keep this part commented. Okay, so we do not part for now. So what do we need? So we need a counter variable, either a counter variable or a flag, this one. Okay, and we need a target variable. For instance, this is our array. So what kind of array is this one? Is an integer type array, right? So it is, my data is my array name and it contains integer type values. So these are the values, initial values for my array. Okay, so for instance, we want to search whether number 5 or any number, let us say 5. So int target. So int target equal to 5. Whether our target is available in this array or not. Okay, so we need to say either this part, either flag, this is called flag, boolean bool flag, okay, equal to false initially, or counter equal to 0 initially. So in counter, we want to say, we want to count how many times an element exists or target exists. Okay, and then flags a bool. So in this is C#. Okay, so we say bool. Okay, remember this programming is C#. So here we will say int counter. So this is the way for int I equal to 0, index equal to 0 to I less than int array dot length. This length is called a property. Okay, so you will learn that later, but for now remember that it finds the length of this array. It will automatically find the length, whatever the elements, how many elements it has, it will tell you. So life becomes easy if you can use this. Okay, so if my starting from 0, if my in array element equal to my target element, then we are saying flag equal to true, and also we are increasing count by 1. We say count equal to count plus 1, or we can say this count plus equal to 1, same thing. Or you can say count plus plus, that also works. Okay, so now at this point what we want to do, we want to display this. Just in order to save my time, I'm just copying and pasting codes. Okay, so if my flag, this means if flag, that means if my flag equal logical equal true. This is the code you will see a lot in your some books or in higher level programs, that people instead of writing this, they write shortcut way, if flag. That means if flag equal to true. Then we want to just give a my number target is found, how many times it will say. If it does not, then it will say it's not found. Okay, so let us run this program. sorry, it says the name int array does not exist. Okay, actually say okay, so array should be my data. Here in this case I changed my code. So my data. Okay. Okay. So this is my hello world. This part is running. Okay. And this is the so this code is internally working, but there is no output statement here within this block. But we have output statement in line number 62 and 64. So here in this case, we are getting 5, right? Here it matches. So it says 5 is found how many times? 2 times. You see one here and another one here. So instead of 5, we search for 15. What do we expect? Can anyone speak from online? Instead of 5, if we search for 15, what should be my output?
My number is not found.
Yes.
Yeah.
15 does not exist here, right?
No.
15 does not exist here, so it will say my number 15 or the number 15, whatever you say. Anything you say, the number or my number, whatever you say, that is not an issue, right? So this is a simple. Okay, so this code like these are this. Okay, so instead of this, actually you can say this. You can say this. Instead of this, you can say this. If flag equal true. Okay, or even instead of this, you can say if counter greater or equal to 1. Okay, so then it will work same thing, but it says this is a warning. Okay, it says flag is assigned but its value is never used. It's okay. Okay, so it says the program is 15. Okay, so even we can make another change here in line number 6. Can anyone please tell me what other change I can do in line number 60? Is there any way that we can change? We can make a different code, different statement in line number 60. Do you think is there any way that I can write another different statement in line number 60?
Can you write does not equal false?
Yes. So here, okay. So actually, we will come there 62. That is line number 62. Okay.
Yeah.
So that
Oh,
is
just
line
60?
number 60.
Oh, okay.
Line number 60.
Greater than 0?
Yes. Thank you so much. You say count is greater than 0, right? Why is greater than 0 will work? So it's a count. Initially, we put 0, right? And then as soon as there is a mass, we are increasing count, right? So definitely what does this mean? If there is a mass, then counter will not be 0, it will increment. So we can say if count greater than 0, then it will work. Okay, and even I can see here, I can, so let us start say with 5, so then it will work. Okay, so this is the way I like you to analyze codes. Okay, and when you get some code, try to understand each of these lines and then make some changes in your code and try to see if it works. Okay, for instance, okay, then let us see another different option to do this. Is there any way we can make a different statement in line number 61? Instead of saying if flag, the easier way maybe the 62. Okay, let me go to line 62. So instead of this, can we write an alternative statement here? What is the alternative statement of this?
If flag does not equal
Yeah,
false.
how do we write that? No, not equal.
Exclamation point.
Exclamation point equals.
Yeah, exclamation equal, right? That means not equal to, what do we write over here? Still true or?
It'd be false.
Thank you. Why false, right? Because if it is not false, then it's true, right?
Mm-hmm.
Because you see that initially we put false. But whenever there is a match, we are changing toggle, we are changing that flag to true, right? So that means if it is found, then it will no longer be false, or vice versa. If it is no longer false, then it is found, right? So then still it will work. Okay. So I like everybody to understand or remember or memorize. Whatever I say, I don't like to memorize, but for the beginning you can memorize. Okay, but ultimately I think if you do not understand clearly 100%, just memorize it and try to write your program 3-4 times without looking your code. Okay, blindly. Then I believe you will understand. And I need everybody to understand this clearly. Has anyone any question? Has anyone any question?
I have a question, but it's kind
Yes.
of unrelated to the search algorithm.
Yeah, go ahead, please.
The if statement at the bottom, how is that working without the curly brackets?
So, okay, that's a good question. So if there is only single statement associated with if, then curly brace is not required. So there is only one statement, right? This is only single statement, right? This is only one statement. Even if you see 2 lines, this is part of this only one line, right? If it is one line, then curly brace is optional. But if there are multiple lines, then curly brace is required. So you are talking about this, right?
Yeah.
Okay, you understand? If there is only single line, then curly brace is optional. That means you can give it or you cannot give it.
All right. Thank you.
Okay, anyone has any other question? I like everybody to understand this. There is no way that we can skip this. Yes. I cannot hear you. Can you please speak loudly? Where are these materials? No. So are you asking about slides, PowerPoint slides, or my programs? Yeah, my programs is in my Replit account. You know I have a Replit account. You have a Replit account? Okay, so search in Replit account, go to repl.it and search, type in @add and type in my name MOKTER. Okay, one thing maybe I can give this code in the chat window, right? I can give this code in the chat window. Yeah, I gave it in the chat window. You see it? Go to the chat window, then you will see this code. Click over there, please. No, chat window of Microsoft Team. Can you please tell him? Okay, so Jerry, so it is announcement. You got it? Okay, everybody is good, right? Okay, so if you are good here, then we can proceed for the different algorithm. Okay, another algorithm. So you see that one of this, do you see any advantage or limitation, disadvantage or limitation of this algorithm? Do you see any limitation of this algorithm?
Yeah.
What
It's
is
so
that?
slow.
Okay, it may be slow, and the reason in that case, if this length array size is very large, okay, it will be slow. For this kind of a short program, we will not face any issue. But think about that, if this array, it contains thousands or millions of elements, like census data, right, in a large database, where there are millions of data. So then, in order to search a specific element, we need to go all the way end. For instance, in this case, in order to find 5, we need to go all the way end. Then that is the worst case. Okay. So there are alternatives algorithms. There are alternative algorithms in order to do this efficiently. One of these is called binary search algorithm. Okay, so in the binary search algorithm, it is easy to find and it takes less time, but there is a limitation and requirement to use the binary search algorithm. The requirement to use the binary search algorithm is that your array must be pre-sorted. The array must be sorted either in ascending or descending algorithm. Okay, so in this case, we discuss this array is not a sorted array. It is random array, unsorted array, right? So elements are coming in any order. So there's the top one is there like 20, then the smaller element, then again largest element, it lies between. But in a case, if you have all the elements are sorted either in ascending or descending order. Ascending mode means starting from the smaller element and going all the way in the largest element. And descending means starting from the largest element and going all the way to the end is the smallest element. Okay, in this way we can have an alternative algorithm. This is called binary search algorithm. Binary search algorithm, it takes log n. Log n means, if you recall logarithm function from your high school, then so how many of you recall logarithm? So for instance, in this logarithm we means, so log base is 2, 8. Okay, equal to log base 2, 2 to the power 3, right? Equal to 3 log 2, 2 equal to 3 into 1 equal to 3. Everybody knows this, right? So this is logarithm, right? Okay. So for instance, if I have similarly log 2 of 1024, that means log 2 of 2 to the power 10 equal to only 10. Okay, so it takes way less element of time. So for instance, if you have 1024 elements in an array, by using binary search algorithm, you will need to do only 10 search, 10 times search. Okay, but whereas in our linear search algorithm, we need 1024 iteration searches. So which one is better? Doing 10 iteration or doing 1024 iterations?
10.
10, right? Okay, definitely yes. So even if you see that you have, now go, let us see, log, say 2 times 2048, right? Equal to log 2 to the power 11. That will take 11 searches. Okay, now if you have 2048 elements, and then you need to check whether an element exists or does not exist. Only 11 iterations. It's way better, right, than the linear search algorithm, where it takes log n times, and it takes log n times. So okay, linear search, it takes n time, big O n in linear search, and it takes log n. It takes it's here already. So it takes log n. Okay, so it's way better, right? So we know that is way better. So then it's better, but there is a limitation. There is a restriction that in order to use binary search algorithm, okay, in order to use binary search algorithm, our array must be pre-sorted. Okay. So if we know that, if we already know that the elements are already pre-sorted in a database, then we can use binary search algorithm. Has anyone any question so far? So the linear search algorithm, the binary search algorithm has some advantages or disadvantages, right? The first disadvantage is that the array must be sorted, otherwise it cannot be applied. Or if you think that if the array is not sorted, right, then we can sort it first, and then we can apply binary search algorithm. But sorting takes way long time. The best sorting algorithm, even the best sorting algorithm that takes the best sorting algorithm takes big O in log n times. So you see that it is n log n, that means log n multiplied by n, right? Okay. So that means if my array is not sorted, then using binary search is not efficient. We will not use binary search if it is not sorted. Okay. You may ask a question that, okay, I will sort my array. It's okay, but sorting takes another, at least if you use even the best sorting algorithm, that will take only again n log n time. Then after you are taking in log n time, then after you can do another log n time. So that is way, like, that is still greater than log n, right? That we can do in linear search algorithm. Okay. So now we got idea about two different kinds of searching algorithm, right? linear search algorithm and binary search algorithm. Okay, now let us see the process how the binary search algorithm works. Okay, binary search algorithm. Okay, again, before we go to this discussion, I like everybody to remember how the linear search algorithm works. Everybody understand that? We start from the beginning of an array, right? And search one by one each element. This is straightforward, right? Everybody understand, remember this? Yeah, I like to hear your voice, people who are joining online.
Yes.
Okay, yeah, I am telling you that I like you to remember that in the linear search algorithm, we start from the beginning of an array and we go all the elements one after another. Okay, but binary search algorithm, it is different, quite different. It's completely different. Okay, so how we do search in a binary search algorithm? So, for instance, we know that our array is already sorted in binary search algorithm. If it is not sorted, we cannot apply binary search algorithm. Okay, assume that, let us assume that we have 32 elements in an array. If you understand this example with 32 elements, then you will understand with any number of elements. So these 32 elements, we can divide them into two halves, right? The first 16 elements and the second 16 elements, right? Okay, remember that these are sorted. Let us remember that these are the smaller elements and these are the larger elements. So definitely all these 16 elements are smaller than these 16 elements. All these left side 16 elements are smaller than the right side 16 elements, right? Now what we can do, we can so let us see that our target, we have to have a target element that will be searching, right? So if our target elements, for instance, is 5, so that 5 will leave either this side or that side, left side or right side, right? Because all of the elements are sorted, our target element will remain either in left side or right side. If my target elements, or it can be in the middle, right? So what we can do, we can find the middle position and we check whether my target element is the middle. If it is in the middle, then we are good, we are lucky enough, right? But if it is not in the middle, then we will check if it is less than this element, if it is this side, left side or right side. So if it is left side, for instance, let us assume that it is in left side. So then again we will split this 16 elements to 8 and 8 elements. Now we will check whether my elements exist in the middle or this left side or right side or this left side. And in this case we completely will forget that right side, because we do not need that right side, right? Because if our elements is on the left side, we do not no longer need the right 16 elements. In this case, every time you see that we are dividing by 2, we are making our array size half, right? So this is the beauty, use the implication of log n. Okay, again we will see that either this side or this side. So then if it is, for instance, this side, so then we will make this another split. Okay, and then again we will check either this side. If it this side, then we will make another split, right? And in this case, if it may be this side or this side. So then what will this, for instance, if it this side or this side. So now we have only one element and it is easy to check our target element, right? So how many iterations or how many chopping we do have? 1 here, then 2, 3, 4 and 5. So for 32 elements we need, for 32 elements log to 32, right? equal to log 2 to the power 5 equal to 32, right? Equal to 5. So only we need 5 iterations to search an element in a binary search algorithm. Okay, so this is the logic of using binary search algorithm. Okay, yes, you have a question? What is the highest? Okay, that is a good question. He said, what is the highest power? For instance, we said you are asking me this question, right? So we say I said log 2, say for instance x to the power y equal to, so you say what is the power of y, right? What is the value of y, right? I don't know this answer. So what is the maximum, the greatest number? Can we know that what is the greatest number in real world? Okay, we don't know yet. People do not know what is the greatest number. Okay, if you write in a whole day, yeah, that is why I'm going. In our last lecture, we discussed the one thing that is called say Java or C# is same thing. Okay, if you say Java, data types and range. So for all operation, all kind of operation, we have to remember the range. So if you say your data type integer, okay, then your must be the power values. For instance, this. If we say this, so this. If you your array size, is integer type, okay. So that maximum, then it can hold this number of value. So in that case, your log 2 of n must be less than 214748364 It must be less than this. Okay, you cannot use comma. Okay, so this you need to use in a way, such a way that n to the power like m or something, else less than this. Okay, for now we don't need to think about. Good question, but don't ask that question. Okay, like that is an abstract question. Okay, abstract question. We did agree that we will not go through in depth about some abstract stuff, right? In real world while learning. But that is a good question. Okay, if this question comes to your mind, that you are thinking in depth. Okay, something that even I did not think today to discuss. Okay, anyone has any other question? Someone asked me a question, what is the maximum element size we can go, right? So we need to actually remember for all operations, we need to have this range. We need to remember the range of the data type. Okay, now let us see. Oh, that is what is the thing that I discussed. Okay, even you see that if there are 4 billions of data, then we need to only 32 iterations, only 32 steps. By using only 32 steps, we can search whether an element exists or not in 4 billion data record. Okay, so for instance, and what is the population of USA? US population 2020. Okay, 333 million people, right? USA has about. Okay, so now let us ask a question. So how if we have a database, census database that is already sorted, right? Then how many iterations we need to search an ID, okay, if the ID are sorted, okay, in the census database with 332 or 333 million people in the USA. So how many iterations we need? If we want to search a specific person's, say, ID number, if the ID number are already sorted 1 2 3 4 5, something like this, okay, maybe 0 1 2 3 4 5 or up to 331 million people USA has, how many iterations we need using binary search algorithm? Can anyone please tell me?
28 or 29.
No, you're close but not exactly. Try again, please. Oh, 4 billion, right? Just 4 billions, right? Yeah, you are correct. Yeah, you are correct. It's less than 30, right? So it says 4 billion, right? So in the if it takes 32 for 4 billion, so you say divided by 2, then it will take 31. Again, if you say divided by 4, then it will take 30 iterations. 1 billion, right? Then yeah, 28 or 29. Okay, so you see the way less than like binary linear search algorithm, right? Good catch. Thank you so much. Okay, so this is the binary search algorithm. Okay, for instance, what do we need? We need to put a low. This is the low index or lowest index of an array, right? We start from 0, and we need to find a mid index, middle element, and then we need to say highest index. So how we can find the highest index? By finding the number of elements in the array, right? If my array is Z, we can easily find that, okay? And say while true, then what we will see? These are the algorithms. So what we are doing over here, we are first start finding the middle index. How do we find the mid index? Equal to low plus high divided by 2, integer division. Okay, if my target, then you will check if my target value is at the middle. Then we are lucky enough. We will say target is found. If it is not, then we will check whether my target is left side or right side of the middle element. So this is my middle element value. And in mid is the middle element's index. Okay, so now at this point, let us recall. Are you clear about the value and index of an array? I'm asking a question to everybody, okay? Are you clear about the value or index of an array? So if this is my array, okay, so you start 0 index, 1, 2, 3, 4, maybe all the way, say maybe this one, say 1023. So my total array size is, say if my array is X, so then array X size, total size is
1024.
yeah, 1024. Thank you so much. Okay, and the last index will go 1023. So these are the values. So 0, 1, 2, 2, whatever I do have values. So 5, 5. Okay, these holds values. Okay, these holds values, and these are the indices. Okay, so these will be my mid index. Is 0 plus 223. So here will be the mid index will be 0 plus 1023 divided by 2. So integer division. So what will be my value? then 5, and then 1, 1, right? So we are making an integer division, right? We are making an integer division over here, so that 0 plus 1023 equal to 1023 divided by 2 equal to 15.5, but we are not taking point, right? So we are doing integer division here. So this is how we get our middle index, and the value will be here, exactly value will be here. So if we say, so this will be in decoration part. So this will be in, we'll find in declaration part. Declaration part, okay? And body part. In your body part, if we say mid, G mid, that means this will be G 511. Okay? So everybody clear about the indices and values? Okay. Now, if my target element is less than the mid value, we say this is mid value or value at the midpoint. Okay, and this is mid index. So we can say here mid index, and we can say here this is mid value. Okay, mid is the middle index, and here you want to say G mid is the value of middle index, value at, right, at middle index. So everybody understand this?
Yes.
Okay, I need to remember this. Okay, don't confuse about this. Okay, so if my target value is less than the value of the middle index, value at the middle index, then what we will do, we will change our high to middle, because let us go back to here. If our target value is less than this side, then we do this is the highest position, this side. This is the highest position. We do not need to go all the way in, right? This is the maximum point we need to search. This is why what we are changing here, we are changing our high value. Otherwise, so otherwise else, man, that means else means if my target value is greater than, okay, is greater than value at the middle index, that means we will go on the right side. If we go on the right side, then what do we need to change? Can anyone please tell me? If we go in the left side, then we keep the low index same, but we update the highest index by middle. But my question is that if we need to go to the right side, what do we need to change? What do we need to change in this algorithm? What do we need to change? Do we need to change the low index or middle index or right index?
Need to change your low.
Yes, thank you so much. You understand, right? So that means we need to change our low by what? By mid. Because in that case, this will be your lowest point, right? Your value will be either from here or any from the right side. We do not need to come all the way left side. This is why in this case we will change our low index by mid. So this is the main point of these two lines, the main points of our algorithm. I'm sorry. So everybody now check whether you understand this. Actually, this is the focal point of this algorithm. Everybody understand this? This is the main point for algorithm. So have a look again, please, everybody. And if you understand this or not. Has anyone any question about this? If you are new, this is the first time you are hearing about this, then this may be a little bit confused. Okay, because confusion comes sometime over here. Why I am finding the mid. Okay, and how it works, right? I showed you with the block how this works. So the mid works. It finds the middle index. How that is calculated? By an integer division. We know that an integer division gives us an integer result, right? It does not give as a fractional value, right? So even it is 1023 divided by 2, 1023 divided by 2 equal to 511.5, right? 511.5. But we are not considering the 0.5 part because our value mid is integer type. So then all indices are integer type, right? We will get these indices. And then if we find that, then what we are doing? We are checking whether our target is at the middle. If it is at the middle, then we are lucky. If it is not in middle, then definitely it will be in the left side or right side. Okay, if it is in the left side, then we will change the highest index, high index. And if it is in the right side, then we will change the low index. So in order to work with this algorithm, I like everybody to remember this slide. You can, if you imagine this slide in your mind, okay, then it will be easy for you to do this. Okay. I like for some time take a picture of this slide, okay? Take a picture of this slide on your phone, okay, and some time to time see this picture or sometime draw it by yourself on a piece of paper. I think if you draw it 2 or 3 times or 4 or 5 times maximum, you will understand this. Okay. And here actually this is the middle point. So this is the midpoint, okay? So I wish I would update this slide better way. This is the midpoint. So this is the mid here. This is mid. Again, I'm sorry. Then again it is mid here. Then again it is mid here. Again this is mid here. Okay, so if we understand this algorithm, then implementation is same, right? This algorithm, if you understand, then this implementation is in Java. It is like this, and C# it is like this. Okay, and C++ almost same thing. So I think I should have to binary. Okay, binary search algorithm, binary search example in C++. So I have code C++, Java and C#. We discussed with C#, and C++ is same thing. Yeah, Java is same thing, but C++. Let us see this code in C++. Okay. So in C++. So okay, so this one I discussed with 2 different types of binary search algorithm. Okay, there are slightly different version of binary search algorithm. Binary search 2. Okay, these are the algorithm. Okay, now let us, people who are taking C++, okay, give attention please. Okay, give attention please. For now, let me. Okay. Actually, these are the codes. Okay. Int target equal to say 5 or value say. Okay. Here my data is my array, so I will say my data here, and my data. Okay, this is I don't need return here. So if I do not use any method, okay, so this program was part of using discuss method. So this is my program code in C++. Okay, let me run it. Sorry, it is going to an infinite loop because while not found, so I need to change found. Okay, I need to change found equal to found equal to true. Okay. You will understand the later. So because of the lack of this statement, it is going to an infinite loop. If you see that, if I do not have this only this line number 50, then it goes to an infinite loop. But if I give this line number 50, then program will work. Okay. What I wanted to give a reminder for the C++ people, okay? Okay, C# and Java has this length attribute. So it is easy to find the length of an array just by using array dot length in C# and in Java just L is in lowercase. Okay, but in C++ does not have the length attribute. So how can we find the size of an array? We say size, okay, or length of an array by this is the way. So we say size of C++ has a size of method. We say size of what is my array name over here, my array, and divided by size of int. What is the size of int? Is 4, right? Size of this data type. Even you can say straightforward, the size of int variable is 4, right? So instead of divided like this, you could divide by 4 over here. But this is the way to find the size of an array in C++. So in C++ code, please remember this, okay? Please remember this for C++ people. For C++, please remember this. Okay? I don't have any shortcut way other than this to find the length or size of an array in C++. Then the remaining codes are same. Okay.
Clarification question,
Yes.
Doctor. When we're getting size or length, that will give us the total number of elements, correct? Not necessarily the final index?
No. That will give you this. For in this case, what is the total number of 1, 2, 3, 4, 5, 6, right?
Yeah.
So if you add up one more element, 17, it will get 7 automatically.
Okay.
If you add one more element, then it will get 8. Okay. You could use manually size equal to 8, right? But so if you use manual size 8, your program will not work for if you change these elements. If you add any elements or if you remove any elements, it will not work, right? So instead of using your fixed, this is the size, fixed size variable over here, you could save size equal to say distance 8, right? In this case, you could say size equal to 8. But instead of saying size equal to 8, if you use this code, then you can work for any number of element. So although it is new, and please remember this, for C# code is a C++ code, and for C Java people, it's easy. L is in lowercase, okay, and C# L is in uppercase length, okay. But this is the different in C++, okay. Do you understand this? Okay. Yeah. Now I like everybody to practice these two programs: binary search algorithm and linear search algorithm. Okay, before you come to your next lecture, please practice these two programs. Okay, and in your test you will get either one, either binary search or linear search algorithm. Okay, I like you to write down this algorithm several times on a piece of paper. Okay, I think if you write 3, 4, 5 times, then you will memorize. It will be clear for you, right? Okay. Honestly, sorry, I don't know any more easiest way to teach this so far. And apparently that it seems to you easy, right? But it will be persistent. It will get persistent in your memory if you practice this program. If you do not practice this, then you will forget. Okay. Has anyone any questions so far? Okay, in our next lecture, we will discuss sorting algorithm. Okay, but in order to do sorting, we need searching algorithm. If you do not understand these two searching algorithm, linear search and binary search algorithm, you will not understand sorting algorithms. But if you understand these two linear search algorithm, then hopefully in my next lecture I can cover all of these three searching algorithms, sorting algorithms. Okay, it will be easy. Okay, so yes, please, everybody, please practice these two programs. Okay, and thank you so much. So people who are online, has anyone any question?
All good.
Okay, thank you so much.
Have a good day.
You too. Bye bye.